September 20th, 1943. The North Atlantic, 700 miles southeast of Greenland. Convoy O202 is running west. 37 merchant ships, 12 escorts. Between them, they are carrying fuel, steel, and food that Britain cannot survive without. At 2010 hours, the destroyer escort HMCS St. Croix is holding station on the convoy's flank, hunting a U-boat contact. She has done this 100 times. Steam ahead, listen, react, survive. At 20:52 hours, something hits her that no ASDIC operator on board has ever heard coming. St. Croix sinks in 9 minutes. 81 men go into the water. The rescue ship HMS Itchen pulls survivors from the freezing sea through the night. Within 4 days, Itchen herself is gone, along with the corvette Polyanthus. Combined losses from Convoy O202 and its sister convoy ONS-18, 3 warships, 6 merchant vessels, hundreds of sailors, most of them still unaccounted for by the time the convoy reaches Newfoundland. The Royal Navy has controlled the sound of the ocean for 2 years. Now something is using that sound against them. The question nobody in Western Approaches Command can yet answer: if the torpedo is listening for the ship, how do you stop a ship from being heard? For 2 years, the Allied advantage in the Battle of the Atlantic had rested on one assumption: a torpedo travels in a straight line. Escort captains were trained to outturn it. Convoy doctrine built entire evasion patterns around that single fact. Zigzag on warning, present the narrowest silhouette, let the torpedo pass astern. Gunnery officers drilled it. Convoy commodores briefed it before every crossing. It had worked, with adjustments, since 1941. The German T-5 Zaunkönig, designated NAT by Allied intelligence, German naval acoustic torpedo, broke that assumption entirely. It did not travel in a straight line. It listened. Twin hydrophones in its nose picked up the specific frequency band of a destroyer's propellers, roughly in the range of 24 to 24 knots of screw noise, and steered toward the loudest source in the water. Speed, which had always meant safety, now meant a louder signal. The faster an escort ran, the easier she became to find. A destroyer accelerating to drop depth charges on a submerged U-boat was, without knowing it, painting a target on her own stern. Western Approaches Command's initial guidance to escort captains was to reduce speed to below 10 knots when a torpedo track was suspected, a defense that left ships nearly stationary in a U-boat engagement zone, and one that several commanding officers considered close to indefensible in an active battle. Slowing down in the middle of a wolfpack attack ran against every instinct 2 years of training had built. The 10th Escort Group, hunting the Luthen wolfpack that attacked ON202, had no countermeasure at all beyond that recommendation. Their ASDIC could detect a submerged U-boat at ranges up to 2,500 yards. It could not detect or deflect a torpedo already in the water and already hunting. The Admiralty's Anti-U-Boat Division, in an internal assessment circulated that autumn, described the acoustic torpedo as a weapon for which no proven counter yet exists. That was not an exaggeration. It was an accurate description of where the science stood. Laboratory staff at Teddington and the Admiralty Signal Establishment had theorized about acoustic homing for years. It was, after all, the same physics behind their own ASDIC. But theorizing about a threat and fielding a countermeasure against it within weeks were very different problems. Everyone involved, the escort captains, the convoy commodores, the scientists at the Admiralty Research Laboratory, was working from a war that no longer applied. The rules had changed underwater, silently, and the men fighting it were still following the old ones. Before the war, Edward Sylvester was not a naval officer. He was an acoustics engineer at a Manchester engineering firm, testing the resonance of industrial machinery, figuring out, essentially, why certain metal components vibrated at frequencies that fatigued and cracked them under sustained load. It was precise, unglamorous work, measured in decibels and cycles per second rather than anything resembling combat. In 1940, he was seconded to the Admiralty Research Laboratory at Teddington, assigned to underwater sound propagation, the physics behind ASDIC's ping and echo. Most of his work involved cataloging how different hull shapes and speeds produced different acoustic signatures, building a reference library nobody outside the lab found particularly urgent. He spent months recording propeller noise from corvettes, frigates, and destroyers at varying speeds, logging frequency ranges that seemed, at the time, like housekeeping data. That data became the entire war the moment German engineers weaponized it from the other direction. Sylvester's specific instinct came directly from his factory years. When a machine vibrates at a frequency you cannot eliminate, you don't try to silence it. You build something nearby that vibrates louder at the same frequency, and let the resonance transfer there instead. He had used that exact principle to save turbine housings from fatigue cracks in Manchester, giving the vibration somewhere easier to go. In October 1943, reading the first loss reports from ON202, he pulled his own pre-war acoustic data and wrote a 2-page memo suggesting the same principle could save ships from torpedoes. You could not make a destroyer silent, not at any speed that mattered in combat. But you could build something louder than the destroyer and put it where the torpedo would rather go. Sylvester's proposal was simple on paper. Build a noisemaker, tow it behind the ship on a long cable, and let it outshout the propellers. The gnat's hydrophones would lock onto whichever sound source was loudest within its detection cone. Make the decoy louder than the ship, at the same frequencies the ship produced, and the ship survives. The resistance he met was not personal. It was procedural, and it made sense on its own terms. Towed gear at speed created drag, cut convoy escort speeds further at a moment when speed already felt scarce, and risked fouling a ship's own screws, a serious concern for officers who had spent 2 years learning that speed was survival, not a liability to be dragged behind the hull. The director of anti-submarine warfare's staff also questioned whether a passive decoy, unpowered and towed, could truly outcompete a target as large and mechanically loud as a destroyer at close range, or whether it would simply add a second target for the torpedo to choose between. A coin flip rather than a solution. Sylvester's design, built in weeks at Teddington workshops using material already on hand, was almost aggressively unsophisticated. 2 hollow steel pipes, roughly 4 feet long, mounted on a towed frame and banged together by the ship's own wake turbulence, generating broadband noise across the gnat's listening frequencies without any motor, battery, or moving part beyond the sea itself. Early bench tests in November 1943, run in a tow tank against a captured acoustic sensor array recovered from a downed German aircraft component, showed the device produced sound pressure levels 15 to 20 decibels above a corvette's own propeller signature at matching frequency ranges. On paper, it should win every time a torpedo had to choose between the 2 sources. If you want the full technical breakdown of how sound-homing torpedoes actually track a target, and why something this crude could beat something that advanced, the sources are linked below. It's a stranger piece of physics than most people expect. The idea nearly died in December 1943, when a fast fleet trial off Northern Ireland damaged the tow cable on 2 ships, and one report described the resulting drag as operationally unacceptable for convoys already running under sustained U-boat pressure. For several weeks, the device, now designated Foxer, sat without an approved deployment order, while officers debated whether the cable, winch, and reel design could be reworked in time to matter before the winter convoy season peaked. Production orders were held pending a fix that, in December, did not yet exist. February 1944. Convoy escort duties resume, with Foxer gear fitted to select escort groups operating in the western approaches. A corvette streams Foxer for the first time on an active convoy run. The gear trails 200 yards astern on a reinforced cable, the reel design reworked since December to handle sustained towing at up to 15 knots. The two steel pipes, dragged and battered by the wake, hammer against each other continuously. To ASDIC operators aboard, it sounds like nothing they've heard before. A harsh, mechanical clatter layered over the ship's own engine noise, audible even without headphones when the sea is calm. A U-boat fires. The torpedo run is tracked by hydrophone, bearing closing, seconds counting down. It does not close on the ship. It closes on the noise 200 yards behind it. The explosion, when it comes, is harmless. A detonation in open water, well clear of any hull. The shock wave felt through the deck plating, but nothing more. The escort continues on station. The crew logs the attack and keeps steaming. Before Foxer, escort losses to NAT-type torpedoes in the September-December 1943 period ran at roughly 1 confirmed sinking or serious damage incident for every 3 to 4 documented acoustic torpedo attacks against escort vessels, a ratio that, across dozens of attacks that autumn, had cost the Royal Canadian and Royal Navies several of their most experienced escorts in a single convoy season. After Foxer's fleet-wide introduction in early to mid-1944, that rate falls sharply. The Admiralty's post-war analysis credits the device, alongside the parallel Canadian CAT gear developed independently at roughly the same time, with a measurable collapse in NAT effectiveness against ships towing it, though torpedoes still occasionally struck the merchant vessels and unequipped ships sailing in the same convoys, since Foxer coverage expanded gradually rather than all at once. There's a reason the Germans never solved this problem for the rest of the war, and it comes down to one design flaw in the T-5 itself that Foxer exploited perfectly. That's covered in detail in the full write-up linked below. The human cost did not disappear. It shifted. German U-boat crews, whose acoustic torpedoes had briefly restored the initiative in the Atlantic after years on the defensive, began reporting torpedo runs that detonated prematurely on decoys rather than targets, attacks that consumed a limited torpedo loadout without result, in a campaign where each U-boat carried perhaps 12.5 torpedoes for an entire patrol lasting 6 to 8 weeks. For a U-boat commander 3 weeks into a patrol, a wasted NAT was not an abstraction. It was fewer weapons for the rest of the war patrol, in a war where fewer of those patrols were coming home at all. 1944 U-boat losses in the North Atlantic ran well above 1943 levels, a trend Foxer contributed to without being the sole cause of it. Kapitän Leutnant Herbert Werner, who served on U-boats through this period, later described the growing sense among crews that the sea itself had turned against us. Not a literal claim, but a description of a war where every new German weapon seemed to be answered within months rather than years. Edward Sylvester remained at the Admiralty Research Laboratory through the rest of the war, working on successive refinements to towed noisemakers, as both sides adjusted their acoustics in a slow, technical back and forth that rarely made headlines but shaped how many convoys reached port intact. Foxer and its Canadian counterpart, CAT gear, were fitted across most Allied escort vessels operating in the North Atlantic by mid-1944, standard equipment on a fleet that, a year earlier, had no answer to acoustic homing at all. By the war's end, towed acoustic decoys had become a routine part of escort doctrine rather than an emergency improvisation. Germany kept improving the T-5 and its successors for the rest of the war, developing versions intended to ignore decoy frequencies. The Allies kept answering with adjusted noisemakers. Neither side ever fully solved the other's weapon. They simply kept the arms race even, convoy by convoy, until the war ended in 1945. The reframing fact, Foxer never made a single U-boat sound quieter, and it never made a single escort ship faster or stronger. It won by understanding that the torpedo wasn't hunting a ship at all, it was hunting a sound. And a sound, unlike a ship, is something you can fake.